What is quantum computing, and why should financial supervisors in the financial sector care about it? That's the question we're looking at today. My name is Tim Shakesby, and I'm the head of digital finance at EIOPA. So, what is quantum computing? Let's start with the basics. Normal computers use bits, plus, 1, minus. A quantum computer uses qubits. These are not 0 or 1, but they're indeterminate. They can be in between. This is called superposition. This means that with a quantum computer, the computer can operate in parallel on many different values at the same time. Qubits can also be entangled. This means that they can affect each other. What's the result of this? It means that quantum computers can do things that classical computers can't. They can address very complicated scenario analysis in a way that the classical computer just cannot process, because they can deal with indeterminacy, because they can deal with multiple values at the same time. So why does that matter for finance? Well, finance is full of those kind of problems. Finance is full of very hard computational problems related to scenario analysis. In finance, we use risk models that run through many millions of scenarios in order to establish probabilities of outcomes. We use Monte Carlo simulations. And quantum computing offers significant benefits in terms of being able to run those kind of scenario analysis, to better optimize portfolio allocations, to have much more powerful, much more effective and accurate risk simulations, to be able to have more efficient payment systems. These are fundamental parts of finance, so quantum computing could really change how finance works. It's important to understand, though, that quantum computers would not be replacing or do not replace classical computings. Quantum computing, where you have a quantum computer on your desktop, is not the future that we expect. But what it is doing, or what it can do, is really push the boundary of what computers do. It's important in this respect also to understand that quantum computers are actually really tough. It's very hard to make a quantum computer. They're impacted by heat, noise, light, vibration, radiation. They're very fragile qubits. So the engineering challenges in building quantum computing are huge. We don't have quantum computers that can do better than normal computers yet. So why are we talking about this now? This is something for the future. Well, there is a reason, and that is to do with one of the first and most obvious scenarios in which quantum computers could really impact finance, and that is cryptography. So finance and the financial system and infrastructure that we have today is really dependent on encryption. Encryption is at the heart of the functioning of that system. Without encryption, that system will break down. And breaking encryption is one of the scenarios where quantum computing really could have an immediate impact. You may have heard of so-called Q day. This is the point when standard encryption being used today breaks through a quantum computer which is powerful enough to break it. We don't know when that's going to happen. We don't know when Q day is. You can talk to some of the most enthusiastic exponents of quantum computing, and they all say 2030, which is not very long. So that's exactly why, even if we take a much more cautious view, and it takes many more years to solve the engineering problems in relation to quantum, we have to act now to address these issues around cryptography as the first step. So you will see, I mean, if you look online, you'll see that the G7 is working on a plan In the EU, we have an action plan being developed. There will be a Quantum Act next year from the Commission. There is a Quantum Europe strategy, and there are calls to the member states in Europe to work on this issue of post-quantum cryptography. And it's important to understand that post-quantum cryptography needs to work in classical computing. Basically, it's not that we replace the infrastructure that we have with a new infrastructure, but we need to improve the cryptography to make it quantum proof. So this is the immediate kind of task. This is the immediate thing that you will be hearing about in relation to quantum. And the last thought is that world, that financial infrastructure that quantum computing will make possible, we don't know what it will look like now. We don't know exactly how it will change finance, but we're certain that it will change finance. So we have to start preparing ourselves for that world now.